third type of transformation is mirroring. And this is just as it says, this is when we mirror the graph in one of the axes. So there are two types again, there is outside and inside the function, and they are different mirrorings. So the first one is the outside the function transformation, and this is when y is equal to minus f of x. And the effect of this is that it times all y values by minus 1, as you would expect. Or the other way you could say it is it's actually a reflection in the x-axis, and this really helps with sketching. So let's take an example. Let's use the same function that we've kept using. So we're going to do y is equal to minus f of x. Now, if we times all y values by minus 1, we're going to find that the y-intercept is going to change to minus 15 times minus 1, which is going to be 15. So the y-intercept is going to be 15, and we'll say that's somewhere up here. And we're going to mirror it in the x-axis. We're going to reflect in the x-axis. And the thing we're going to find is that the roots are actually not going to change when we reflect in the x-axis, because they are on the x-axis, and also because the y value is equal to 0. So when we times it by minus 1, it doesn't have an effect. So the roots are going to be the same, so we're just going to reflect it. So the best way to do this is I would start at the turning point at the bottom and then reflect it like that. So the turning point's about here. So if I'm going to sketch this, I'm going to do it like this, and like this here, and then I'm going to reflect this part here. So it's going to be like this, and then this part is going to be like this here. And that's how that is the graph y is equal to minus f of x. It is reflected in the x-axis like that. So labeling, we don't need to label the roots because it's the same, and the y-intercept is equal to 15. In terms of the equation, we just times the whole thing by minus 1 because it's y is equal to minus 1 times f of x. So the new equation is just going to be y is equal to minus x plus 3 x minus 5 is the inside the function, and this is of the form y is equal to f of minus x. And the effect of this is that it timeses all x values by minus 1. So it's the x values again for the inside the function, but this is the only time for the inside the function where it actually has the effect that you'd expect it to, because this could actually be divide if you wanted to, because dividing by minus 1 is the same as timesing by it. There's no difference between the two, and it's not going to be plus 1 because that doesn't make any sense, because that wouldn't do anything. So luckily this is the only example, fortunately, where the inside of the function, it works the way that you'd expect it to. And another way of saying this is it's a reflection in the y-axis, and this makes sketching easier. So let's use the same function, and let's sketch y is equal to f of minus x. So the best way to do this is the roots are going to change, and they're going to become minus 3 times minus 1, which is equal to 3, and 5 times minus 1, which is equal to minus 5. So we'll do minus 5 about here, and 3 about here, let's say. Now the y-intercept is going to stay the same, and as it's a reflection in the y-axis, what I do is I would start at the y-intercept and then just draw both sides, kind of like mirror them in my head. So let's do the left hand side first and mirror the right hand side. So it's going to look something like this, and then it's going to come up like this, and then for the other side it's going to look something like this, something like that. And that is sort of a mirror of the graph. I'm just going to make this a tiny bit more straight like that, because that's more of an accurate example. So this root here is -5 and this here is 3, and then that is it mirrored in the y-axis like that. Remember to label it, so this is going to be y is equal to f of minus x. So in terms of the equation, what it's going to do, as you'd expect, as we've talked about with functions before, in terms of how it works, it's going to be the same function, but you need to replace all the values of x with minus x. So it's going to be y is equal to minus x plus 3 minus x minus 5. And just a quick word on equations again. So they might ask you to sketch something like y is equal to x plus 3 x minus 5, and then they'll ask you to sketch y is equal to 3 minus x minus 5 minus x, and you're going to have to again realize the fact that the only difference between these is minus x is replacing x. So you need to realize that in order to get from this graph to this graph, it's just a reflection in the y-axis. Once again, for more complicated example, that's a lot more useful, because then you don't have to figure out the whole graph again. Now let's do the mirror transformations for a quartic. So let's do first of all y is equal to minus g of x. So this is going to be a reflection in the x axis. So the y-intercept is going to become -6, so we'll do that around here, and again I'm going to do it with the turning points. So it's going to look like this for this turning point, and like this for this turning point, and then it's going to wrap around like this, and then come out of the graph like that. And then for this, it's going to come around very small like this, and then come out like this, and the new y-intercept is here at -6. Remember to label this is y equals minus g of x, and that is the mirrored in the x-axis. Remember the roots stay the same, and the equation is going to be y is equal to minus x plus 3 x plus 1, x minus 1, x minus 2. And then for the inside, the function mirroring, it's going to be y is equal to g of minus x, which is going to be a reflection in the y-axis. So that means the roots are going to change to 3, 1, minus 1 and 2. So we'll say that 3 is about here, 1 is obviously here, minus 1 is here, and minus 2 is about here. Sorry, it's minus 2 here. And as it's a reflection in the y-axis, as I said, the way I would do it is I would start from the y-intercept, which doesn't change, and then I would go from there. So if you reflect this, it's going to look like, let's start with this side, so it's going to look like that, and then it's going to come round like this and wrap like that, and then it's going to come up like this, and then the other side it's going to come down like this. It's going to have a very small turning point here, and then it's going to come up like this, and that is the mirrored quartic. I might draw this a tiny bit more bent to be a bit more accurate like that, because that's a bit more of an accurate turning point. And then we can label the new roots as this being 3, this being 1, this being minus 1, and this being minus 2. Remember to label this is y is equal to g of minus x, and if we the new equation is going to be y is equal to minus x plus 3 minus x plus minus x plus 1 minus x minus 1 minus x minus 2, but this will more commonly be wrote, especially the top brackets, as 3 minus x 1 minus x minus x minus 1 minus x minus 2. Finally, let's just do the mirroring transformations in the reciprocal graph. So this is going to be y is equal to minus h of x, and if you reflect in the x-axis, this curve down here will go up to here, so it's going to look like this, and this curve up here will be reflected in the x-axis to go down like this. The asymptotes will remain the exact same, as one of them is on the x-axis and the other one where x is equal to 0. If you reflect it, it's the same thing. Remember to label y is equal to minus h x, and the graph is going to be y is equal to minus 1 over x. And if you remember the reciprocal graphs of what that graph looks like, you'll be able to tell that this is actually the graph that we have drawn here. So that is explanation to actually why it looks like that. And then for the inside the function, where it's y is equal to h minus x, it's going to be a reflection in the y-axis. So this here is going to be reflected in the y-axis to become this, and this here is going to be reflected in the y-axis to become over here and go like that. The asymptotes are going to remain the same. Remember to label, this is y equals h minus x, and the equation is going to be y is equal to 1 over minus x, which you can actually simplify to minus 1 over x, as you can just take the minus 1 out. And that's actually what we've drawn here. We've actually drawn the same two graphs here. So therefore, actually, when you 1 over x, if you mirror it in the x-axis and you mirror it in the y-axis, it is the same graph. It is y equals minus 1 over x. Although do note that for y equals 1 over x squared, it doesn't work like that. They will be two different graphs.